Hello students, welcome you to this video. In today's class, I am going to teach one of the very simple topic, logarithm. And some of you may find logarithm a little tough, but in the lower classes you studied logarithm, right? So just we are going to revise what you studied. Logarithmic function is the inverse function of exponential function. Logarithmic function and exponential function are inverse to each other. Inverse of logarithmic function exponential function, and the inverse of exponential function is logarithmic function. First, you must know how to convert exponential form into logarithmic form and logarithmic form into exponential form. Just listen here. Suppose you have a function or an algebraic expression a raised to b equal to c. How can you write it in logarithmic form? Log c, the number which comes separately, this c. This is as an exponent, right? So here as an answer, the number c. So for that you take log c to the base a is the base, to the base a equal to b. So 5 square is equal to 25. It is in exponential form. How can you change it into logarithmic form? You can write it as, the separate number is what? 25, right? So 25, so you can say log 25 to the base, which is the base here, base is 5. So it will come down. So to the base 5 is equal to 2. So this is how you have to convert exponential form into logarithmic form. Now we check the other one. Suppose logarithmic form is given log x to the base y equal to a. This is in logarithmic form. How to convert it into exponential form? Listen, you start with the base, then just you take cross. So y raised to a, that a goes to the power. So y raised to a. So y raised to a equal to what is left out here? X. Suppose you have log a to the base 7 is equal to 140. So how can you change it? You start from the base. Base is what here? 7. So 7 raised to, the other number it goes to the power. So 7 raised to 140 is equal to a. So hope you understood how to convert logarithmic form to exponential and exponential form to logarithmic, and both the forms are what? Both are inverse to each other. Then some of the important values you remember in log 1 equal to 0, log 1 equal to 0, log a to the base a. If these two numbers are same, then the answer is 1. Then log infinity is infinity only, and log 0 is minus infinity. Log 0 is minus infinity. Log you can take only for positive values. Only for positive values you can take log. So the domain of logarithmic function is, for logarithm, what is the domain? It is 0 to infinity. If you put 0, it is minus infinity, right? So you can't give 0. So you can give up to what? 0 to infinity. This is the domain. But the range is, your answers will be from minus infinity to plus infinity. Okay, so domain is 0 to infinity and the range is minus infinity to plus infinity. Then you must know the laws of logarithm. Everything you studied in the lower classes, just I am revising you. First one is product rule. Log of AB can be written as log A plus log B. This is called product rule, right? But base must be same. So here suppose the base is m. Here also the base is m. Here also the base is what? M. So log A plus log B is log of AB. Log of AB is log A plus log B. So both so you must know. Then quotient rule. What is quotient rule? Log of A by B can be written as log A minus log B. So the base, same base, whatever be the base, suppose the base is x. In all the cases it is what? X. Then the next one is power rule. Log a raised to m. The power comes to the front. Log a raised to m is m log a. Log a raised to m is what? M log a. The base, whatever base you have, you can write the same base. Okay, this is power rule. Then another important thing you need, log a to the base b. You can interchange that a and b, the base and the number a and b, you can interchange. Instead of log a to the base b, you can write log b to the base a. What you do now? You write 1 by. You can write it as 1 by log b to the base a. So you can interchange these two, but you write what? 1 by. Then another thing you need, base changing rule. What is that, you know? So base changing rule. Suppose you have a logarithmic function like this, log a to the base b. Suppose you want to introduce a letter c. So what you can do, no? So write 2 times log. Write 2 times log. You can write it in 2 ways. 2 times you write log. Now, the letter what you want to introduce, suppose I want to introduce the letter C. That C you write cross. Either you write here C, here also write C. Or here you write C and here you write C. The letter which you want to introduce, that you write cross. So, the one you write as a base, another one don't write it as a base, write it as a number. And the another case, just reverse it. Okay, there are 2 ways. Now, fill the other places. A. So, for the first case, B is in the base, right? So base is here. So write B here. And A is the number already here. This place filled. So write here A. In the second case, that base B here already written. So write base B here. And A you write here. Okay. So these two, if you see the cross, if you see they are what? Same. Then you can leave that and your answer is log A to the base B. The first one, these two are same, right? Leave that and what's your answer? Log A to the base B. So like that, you can simplify also. Listen, suppose if you have log a to the base c into log d to the base a, can you simplify? Yes, these two are same, a. So leave that. So what's your answer? Log d to the base c, right? Log d to the base c. So this is called what? Base changing rule. It's a very useful one. So that's all the things what you. Then with this idea you can do the sums and some exponents. In simplification you need some of these. What you know, root a, what's the meaning of root a? A raised to half. Root a means a raised to half. So a raised to half, it is root a. A raised to 3 by 2. 3 by 2 means 1 and a half. 3 by 2 means 1 and a half, right? So you can write it as a raised to 1 into a raised to half. A raised to half is same as what? Root a. Suppose a raised to 5 by 2. What is 5 by 2? 2 and a half. So a raised to 2 and a half. You can write it as a raised to 2 into a raised to half. So hope you understood that. Okay, so with this idea we are going to do the sum. So remember mainly what you studied new, the domain and range. What's the domain of logarithmic function? 0 to infinity. Open interval 0. Okay, 0 to infinity. And the range is minus infinity to plus infinity. All of the results what you studied in the lower classes only are revised. Okay, so now we move on to the sums. Look at the first question, very simple question. B greater than 0 and B not equal to 1, y equal to B raised to x. Express y equal to B raised to x. Express y equal to B raised to x in logarithmic form. It is given in what? Exponential form. They asked to convert it into logarithmic form. Very simple, right? So log of the number which comes separately is y to the base what? B equal to x. That's all. So exponential form we converted into logarithmic form. Then what else they asked? Also state the domain and range of logarithmic function. So domain of logarithmic function is 0 to infinity. Then they ask the range also. Range is what? Minus infinity to plus infinity. Now the second sum. So here compute. So you have to simplify this. So there are two expressions. So what I am going to do? I am finding both the cases bases are all different. So I am going to take this first one as x. Second one as y. First one take it as x, second one take it as y, in between minus. So then you find x minus y, that's all. Okay. So I'm going to simplify them separately. So let log 27 to the base 9 equal to x and log 9 to the base 27 is what? Y. Now let us try to find x and y. After that, write the question that is actually x minus y, right? Then you can just subtract it. So, okay, now from here let us find x. So, logarithmic form converted into exponential form. So, 9 raised to x. So, from the base you start, then you cross, you multiply 9 power x. Okay, it is not 9x, 9 raised to x. 9 raised to x is equal to 27. Now, 9 and 27, same base you convert. 9 can be written as 3 square. The whole raised to x equal to 27 is 3 cube. So, 3 raised to 2x. Hope you know that the last class we studied, right? A raised to m, the whole power n is a raised to mn, right? So, here 3 raised to 3, bases are same. So, you can equate the power 2x equal to 3 or x is equal to 3 by 2. From the second one, you convert it in exponential form. See what you get. 9 is equal to 27 raised to y. Or you can write that first, 27 raised to y equal to 9, everything same. Base 3 you convert, 9 can be written as 3 square. 27 is 3 cube, the whole power y. So 3 square is equal to, what you are getting, 3 raised to 3y. 3 raised to 3y, right? Now bases are same, so you can equate the powers. So 3y equal to 2, or you say y equal to 2 by 3. Y equal to 2 by 3. Okay. Now listen, x value, y value, got it? Now you see the question. Therefore, we copy the question. Therefore, log 27 to the base 9, log 27 to the base 9 minus log 9 to the base 27. Log 9 to the base 27 is equal to just x minus y, because first we have taken as x, second one taken as what? Y. Substitute the values, x value 3 by 2 minus y value 2 by 3. Very simple calculation. Take LCM, 2 3s are 6. So 3 3s are 9 minus 4. So what's your answer? 5 by 6. Okay, so this sum you can do in this way. Now see the next question. Solve. Solve means it is not true that. Okay, don't start with LHS equal to RHS. No. Solve. Solve means you find the unknown. So what is unknown in this question? X. So you are supposed to find x value. So listen, for these type questions, see what is given here. Log x to the base 8 plus log x to the base 4 plus log x to the base 2. This is what given, equal to 11. Okay. So first thing what you see, no, before log, do you have any number? Before log, nothing. Just one only, right? If there is some number, you take it to the power. But here nothing like that. So, but you can't simplify this because the bases are all different, right? But you can see the numbers are same, log x, x, x. So, we take it to the base. So, how can you interchange base and the number? X and 8 I want to interchange. So, what you can write? 1 by log 8 to the base x. Hope you understood. Plus 1 by log 4 to the base x plus log 2 to the base x. Sorry, 1 by, right? 1 by log 2 to the base x is equal to 11. So, now in the next step, you can write 1 by log 8 can be written as 2 cube to the base x plus 1 by log 4 can be written as 2 square to the base x plus 1 by log 2 to the base x is equal to 11. Now in the denominators you can apply power rule, right? So 1 by log 2 cube you can write as 3 log 2, right? The 3 goes front, 3 log 2 to the base x plus 1 by log 2 square, apply power rule, the 2 comes front, 2 log 2 to the base x plus here nothing, 1 by log 2 to the base x is equal to 11. In all the cases in the denominator you can see, right side is 11, 1 by log 2 to the base x is common in all the terms. What is left out? The first one 1 by 3, second one 1 by 2, third one nothing, you take it as what? 1. Now we take LCM for this 3 and 2, LCM is 6. In 6, 3, 2 times 2 into 1, 2 plus 6 divided by 2, 3, 3 into 1, 3 plus 6. So this is what you are getting. Now this 1 by log 2 to the base x, you convert it again, take it to the numerator. So interchange the 2 and x. You can write it as log x to the base 2 equal to 11. Add the numerator, you are getting 11 by 6 into log x to the base 2 equal to 11. Both the sides you cancel 11, or log x to the base 2 is equal to 11 into this 11 by 6 you take it to the other side, it becomes 6 by 11, right, into 6 by 11. So 11 11 you can cancel, so you are getting log x to the base 2. You are getting log x to the base 2 equal to 6. Logarithmic form converted into exponential form, so you are getting x is equal to 2 raised to 6. So that is x is equal to 2 raised to 5 is 32. 2 raised to 6, 32 into 2, it is what? 64. It's a very important question. So like this they can frame different questions. By seeing the question you can understand. See, here everything same, x. Bases are different, but some powers, right? 2, then 4, 2 square, then 8, 2 cube. So here the method is you write 1 by, so that you can interchange base and the number. Okay, so then apply power rule, something common, take it out. Okay, this is how you have to do these type questions. The method you study, so like this they can frame any question, you can do that. Okay, now see the fourth question. Listen, sum number 4. Solve again to find x value. So log 2 raised to 8x to the base 4 equal to 2 log 8 to the base 2. So what I am going to do, left side let it be, we cannot simplify that. Right side you can simplify. 2 raised to log base 2, 8 can be written as 2 cube. 8 can be written as 2 cube. So that is 2 raised to, apply power rule, 3 comes front, 3 log 2 to the base 2. What is log 2 to the base 2? It is 1, right? Log 8 to the base a is 1. So you are getting only 2 cube. 2 cube into 1, right? Into 1, because log 2 to the base 2 is what? 1. So you are getting 2 cube. 2 cube is what? 8. This is the value of log 2 raised to 8x. Log 2 raised to 8x to the base 4. This is the left side is log 2 raised to 8x by 4. Left side we didn't simplify anything, just right side is simplified. So the value is 8. Now we change it into exponential form. So when you change it into exponential form, 2 raised to 8x is equal to 4 raised to 8. So convert it into base 2. 4 can be written as 2 square, the power 8. So you are getting, that is 2 raised to 16. 2 into 8. Left side is 2 raised to 8x. Now the bases are same. It's a very simple question, only thing some simplification. Bases are same, so you can say the powers are equal. 8x equal to 16, x equal to 16 by 8, you will get what? 2. See the next question. What is given here? This is prove that, okay, it is not solved, it is to prove. See what is given here. Given in the question, a square plus b square equal to 7ab. Okay, now listen, here also they can frame different questions, so listen very carefully, no need to bug up. See what we need, according to that you have to proceed. Log a plus b by 3. So what I am going to do, a plus b we want, right? So I am starting with a plus b square. Why? Because we have a plus b. So I am starting with a plus b the whole square. Suppose if it is a minus b, you start with a minus b the whole square. What is a plus b the whole square? A square plus b square plus 2ab, or a square plus 2ab plus b square. Everything same only, right? Why I am writing like this, this a square plus b square can be replaced by what? It is given in the question 7ab. So you can write it as 7ab plus 2ab. So you are getting a plus b the whole square is equal to 9ab. So this is the first step. Now, of course, you need log, right? Before that, see that you are getting this expression. So first a plus b square, a plus b we need, but we got a plus b the whole square. But I want only a plus b, take square root. When you take square root, you will get a plus b is equal to 9 square root is 3, ab square root I am writing root of ab. Next you see only the question you see, show that. So a plus b got it. But now denominator what you have? 3. So a plus b by 3. Yes, 3 we have here, right? So bring it down. So a plus b by 3 is equal to root ab. Root ab can be written as ab raised to half. Now see the left side, a plus b by 3. Now, yes, you got this a plus b by 3, right? So you got this a plus b by 3. Now you take what? Log. So like that you have to study. Okay, so what we have to prove, such a way you have to do. So now taking log on both sides. Taking log on both sides. See what you get here. Log of a plus b by 3. Log of a plus b by 3 is equal to, you take log here, log of ab raised to half. Apply power rule, the half comes front. Okay, comes front. Half into log of ab. That is half into log of ab can be written as log a plus log b, right? Log a plus log b. So what's the left side? Log a plus b by 3. This is what they asked to prove. Log a plus b by 3 is half into log a plus log b. Hope you understood this. It's a very simple question. See the next question. Another very simple question. So again prove that question. We start with LHS because right side is only 0, right? So log a square by bc plus log b square by ca plus log c square by ab. So these type questions, already I said, before the log, you see if there is any number or not. If there is some number, you take it to the power, then only you can apply product rule, quotient rule and all. So here log, before that nothing, 1, the second term, before log nothing, third one also before log nothing, it is 1 only. Okay, straight away can do. Now it is plus log a plus log b. What is log a plus log b? Log of ab. What is log a minus log b? Log of a by b. Here everything plus only. So just you have to multiply. So write single log, log of. First one, a square by bc into b square by ca into c square by ab. So that is log of, numerator is a square, b square, c square. Denominator also, here one a into a square. Like that b into b square, and one c into c square. So everything cancel, right? You are getting log 1. A square, b square, c square, a square, b square, c square cancel. Log 1, the answer is what? 0. Log 1 is 0, and that is our RHS. Now see the 7th question. Again prove that question. Do it very carefully. Very simple question. We start with LHS. Log 2 plus 16 log 16 by 15 plus 12 log 25 by 24 plus 7 log 81 by 80. The answer is 1. So previous one the answer is 0. Log 1 is 0. But here the answer is 1. So here numbers, no? So natural logarithm, the base is not given, you take the base as what? 10. If the base is not given here, you take the base as what? 10. It is understood. So what answer you will be getting? You will be getting log 10 to the base 10. Log 10. If you get log 10, the answer is 1. Because the base is also what? 10 only. Log 10 to the base 10, it will be 1. Okay, now listen how to simplify. As I said in the previous sums, see first step you see before the log. Do you have any number? The first one nothing, log 2. Second number 16 is there, take it to the power. So you write log of 16 by 15 raised to 16, power rule. The third term before the log 12 is there, take it to the power. So you will get log 25 by 24 raised to 12. Next one 7 is there, so log 81 by 80 raised to 7. Now everywhere we have plus, so you have to apply only product rule, right? So you have to multiply the terms, but there is a numerator, denominator there, right? So single log you write very carefully this step. First one is 2 plus, so you put multiplication. Then the power is 16. That 16 is for both the numbers, numerator and denominator. So 16 raised to 16 by 15 raised to 16 into again, because plus is there, no? Power is 12 now. So 25 raised to 12 by 24 raised to 12. Again plus, so you put multiplication. Power 7 now, so 81 raised to 7 by 80 raised to 7. Now prime factorization. So that is log, listen carefully, 2 into 16 means 2 raised to 4. 16 means what? 2 raised to 4. So you can write it as 2 raised to 4 the whole power 16. By 15 can be written as 3 into 5. 15 can be written as 3 into 5. So 3 into 5, but the power is 16. For both of them, the power is 16. 25 is 5 square raised to 12. 24 can be written as 2 cube, right? 24 can be written as 2 cube into 3. For both of them, you give the power 12. For both, you give the power 12. Then 81 means it is 3 raised to 4. 3 into 3, 9. 9 into 3, 27 into 3, 81. So 4 times. 3 raised to 4 raised to 7. 80. That 80 you simplify. 2 table. 40. Again 2. 20. Again 2. 10. Again 2. 5. So 2 raised to 4 into 5. But the power is 7. So for both you give the power 7. Hope you understood all these things. Okay. This step is very important step. Okay. So now that is log of 2 into 2 raised to 64, 4 into 16. Numerator simplify into 5 raised to 24, 2 into 12, into 3 raised to 28, divided by 3 raised to 16, 5 raised to 16, 2 raised to how much, tell me? 3 into 12, right? 36, into 3 raised to 12, denominator another 2 more, right? Into 2 raised to 7 fours are 28, into 5 raised to 7. Okay, now that is log of numerator. This 2 raised to 1, 2 raised to 1, 2 raised to 64, together 2 raised to 65. 3 raised to 28, 5 raised to 24. Same way in the denominator, group 2 powers. 2 raised to 28, 2 raised to 36, that is 2 raised to add the power 36 plus 28, you will get 64. 3 raised to, we have 2 terms, 3 raised to 12, right? 3 raised to 16 and 3 raised to 12. So 3 raised to 16 plus 12, it is 28 exactly. Now 5 power, you see, 5 raised to 2 terms we have, right? 5 raised to 16, 5 raised to 16 and 5 raised to 7. You will get 5 raised to 23. Now listen how to simplify this. That is log of 3 raised to 28 you can cancel. 2 power, you see, the numerator 2 raised to 65, denominator 2 raised to 64. So 2 raised to 65 minus 64, it is 1. 2 raised to 1, so you get only 2. 3 power cancel. 5 power, 5 raised to 24 by 5 raised to 23. 23 times cancel, only one 5 is left out. Or you can do a raised to m by a raised to n is a raised to m minus n. So 5 raised to 24 minus 23, it is 1. So 5 raised to 1 is 5. You are getting log 2 5s are what? 10. Base is 10. So the answer is what? 1, and that is our RHS. Very simple question, but write and practice. Okay. So only some writing work. So before the log, if some terms there, take it to the power. Okay. Then if there is some minus, you have to put division. Then you know how to change division. You change it to multiplication, write the reciprocal, right? You can do in that way. Okay. So then prime factorization, but practice well this question. Now sum number 8. So this is a prove that question. So we start with LHS. Log a to the base a square into log b to the base b square into log c to the base c square. We have to prove the answer is equal to what? 1 by 8. Okay. So what you can do here, you can't simplify now. You write 1 by, so you can interchange a and a square, right? So you can write log a square to the base a into 1 by log b square to the base b into 1 by log c square to the base c. So apply power rule in the denominator. 1 by 2 log a to the base a into 1 by log b square. Apply power rule, the 2 comes front. 2 log b to the base b into 1 by 2 log c to the base c. You know log a to the base a, log b to the base b, everything is what? 1. So 1 by 2 into 1 into 1 by 2 into 1 into 1 by 2 into 1. So numerator is 1 into 1 into 1. It is 1 by 2 into 2 into 2. It is what? 8. and that is our RHS. Now sum number 9. Very simple question. Again prove that. We start with LHS. What is LHS here? Log A plus log A square plus log A cube plus etc. log A raised to n. Very simple question. So you can write log A plus you write 2 log A. Apply power rule. Plus 3 log A plus etc. plus n log A. In all the terms, what is common? Log A is common. Take log A common, remaining 1 plus 2 plus 3 plus etc. up to n. Sum of n natural numbers, you know the formula, n into n plus 1 by 2 into log A, and that is our RHS. So very simple question. Just try to apply power rule, take common value outside, you are getting the answer. See sum number 10. Again prove that there is a condition. What is given here? Log x by y minus z, right? Log x by y minus z equal to log y by z minus x equal to log z by x minus y. These three expressions are equal. I am taking each one as say k. Just I am taking each one as k. Now we take first and last, group first and last. You cross multiply, you will get log x. When you cross multiply, ky minus kz, first and last. Now we take second and last. So log y equal to, right? Log y equal to kz minus kx. Third and last, log z, cross multiply, log z is equal to. So these two you are taking. Cross multiply kx minus ky. Add all the three. Adding all these three values. So left side you add separately log x plus log y plus log z, right? Right side if you add, for the first one ky minus kz, second one kz minus kx, third one kx minus ky, everything get cancelled, right? Plus ky minus kx plus kx, kz, you are getting 0. But left side is same as log x plus log y plus log z, product to log x, y, z. Log of which number is 0? 1, right? So from here you can say x, y, z equal to 1, or change it into exponential form. X, y, z is, the base is not given. Suppose the base is e raised to 0 or 10 raised to 0. Any number raised to 0 is 1 only. Or log 1 equal to 0. Instead of 1 we have x, y, z. So that x, y, z is equal to 1. So three expressions they said equal, and each one you take it as k. From the first you find log x, just to cross multiply. Second you find log y. Third you find log z. Add it, you will get the answer. Okay. Now next sum number 11. Listen, this question is to solve, right? Again you find x value. So what is given here? Log x to the base 2 minus 3 log x to the base half equal to 6. Listen very carefully. First part, no, first term no problem. Second one you do very carefully. Log x to the base 2 minus 3 into, I am writing 1 by, so I am reversing, right? X and 1 by 2 interchange. Log 1 by 2 to the base x equal to 6. That is log x to the base 2 minus 3 into 1 by, log base is x, 1 by 2 means 2 raised to minus 1. Next step, apply power rule, 2 raised to minus 1. The minus comes front, so that minus into minus become plus. So the next step will be log x to the base 2 plus 3 into 1 by log 2 to the base x. How we got this plus? You know, this minus 1, you apply power rule, this minus 1 comes front, that minus comes here, right? Then minus, then here also actually got minus, that minus and minus is what? Plus. Okay, hope you understood that. Equal to 6. Next step, log x to the base 2 plus 3 into, now take it to the numerator, 1 by log 2 to the base x, take it to the numerator, so interchange again, log x to the base 2 equal to 6. Now it is very simple, both are like terms. Log x to the base 2, here also log x to the base 2, here 1 time, here 3 times, so 1 time plus 3 times, it is what? 4 times. So you are getting 4 times log x to the base 2 equal to 6. 2 and 3, right? If you cancel by 2 table, or you do one thing, 4 you take there, log x to the base 2 equal to 6 by 4. So that is log x to the base 2 equal to 3 by 2. We want x because question is solved. Change it into exponential form, x equal to 2 raised to 3 by 2. So that is x is equal to 2 raised to 3 by 2 means 1.5. Early right out, right? A raised to 3 by 2. A raised to 1.5 means a raised to 1, a raised to half. A raised to 5 by 2 means a raised to 2.5. A raised to 2, a raised to half. Same way, this is 2 raised to 1.5. So 2 raised to 1 into 2 raised to half. Half means root, right? So your answer is 2 root 2. Okay, now let's see the next question. Solve again. You have to find x value. Very simple question. Just to change it into exponential form. What is given here? Log x square minus 6x plus 65 equal to base is 5 minus x equal to 2. Change it into exponential form. So you will get x square minus 6x plus 65 equal to 5 minus x the whole square. So this is very important, the theory part, converting. So that is x square minus 6x plus 65 is equal to, you square this one, a minus b the whole square. A square minus 2ab plus b square. Cancel x square on both sides. Group x terms. Bring that minus 10x to the left side. So 10x minus 6x, 4x equal to 65 goes there. So it's 25 minus 65, you are getting minus 40. So x is equal to minus 10, right? Okay, so now you see another few example sums will help you. Find the logarithm of, see what they asked here. Find the logarithm of 1728 to the base 2 root 3. You take this as x. So it is enough to find what x value, right? So change it in exponential form. 2 root 3 raised to x equal to 1728. 1728. Now that 1728 prime factorization. 2 table 864. Again 2 table 432. Again 2 table 216. Again 2 table 108, right? Again 2 table 54, again 2 table 27, now 3 table 9, again 3 into 3. You are getting 2 raised to 6 times, right? 2 raised to 6, 3 raised to 3. So 2 raised to 6, 3 can be written as root 3 square. The whole cube is there. Why I am very particular about root 3, no? The left side we have 2 and root 3. So writing in terms of 2 and root 3. So 2 raised to 6. Root 3 raised to 2 into 3, it is 6. Root 3 raised to 6. So this is power 6. In both the cases, power is 6, no? So together you can write 2 root 3 raised to 6. What's the left side? 2 root 3 raised to x. Now the bases are same. That is why we are converting like this. Actually 3 cube only, right? But I want root 3. 1 3 can be written as what? Root 3 into root 3. Another 3, 2 times root 3, root 3. Here also root 3, root 3. So 3 times 3 times 3 become 6 times root 3, right? Because every 3 can be written as root 3 into root 3. Okay, so power 6. Now bases are same, so I can say the power is also equal. Look at this question, very simple question, prove that. So we start with LHS. Log 75 by 16 minus 2 log 5 by 9 plus log 32 by 243. You have to get the answer as what? Log 2. Already we did a question, but here's a minus also there. That's the reason I thought of teaching this also. So first, before the log, if some terms there, take it to the power. Okay, so you can write as log 75 by 16 minus the 2 goes up. So log 5 by 9 square, or you can say 25 by 81, right? Actually 5 by 9 the whole square, 25 by 81 plus log 32 by 243. So in the next step you can write a single log 75 by 16. Since it is subtraction, you put division. If it is addition, multiplication. Okay, 25 by 81 into 32 by 243. So that is log 75 by 16. Division, you change it as multiplication, right? The reciprocal 81 by 25 into 32 by 243. Now just simplification. See, 81 you can cancel 3 times. 3 table you cancel 25, 25, 25 cancel, 16 and 32 cancel 2. So your answer is what? Log 2, that is your RHS. So that's what they asked to prove, yes. Now look at this question. Solve this. So do very carefully this question, little bit different one, okay. So solve, the question is x raised to log x to the base 3 equal to 9. Here the method is, you take this part as y. Let log x to the base 3 is equal to y. So change it in exponential form, x is equal to 3 raised to y. So you get, what's the question? X raised to log x to the base 3 equal to 9. It becomes, listen, instead of this x, give the value 3 raised to y, 3 raised to y raised to this one. Instead of this x only, I put 3 raised to y. Raised to log x to the base 3. That log x to the base 3 we have taken as what? Y equal to 9. So now you can write 3 raised to y square, because y into y, right? Equal to 9 can be written as 3 square. Bases are same, powers are equal. Y square is 2. So y equal to plus or minus root 2. So we want find x, but x is equal to 3 raised to y, right? So x is equal to 3 raised to y, that is x is equal to 3 raised to y. What is y value? Plus or minus root 2. So you are getting two answers you are getting. So solution is x equal to 3 raised to root 2 and another one x equal to 3 raised to minus root 2. Okay, so these are the two solutions you are getting. Now let's move on to the next question. Look at this question, how to do this. So 3 log compute. So log 5 to the base 3, log 5 to the base 3, log 5 to the base 3 into log 27 to the base 25. Now please listen, first one you can't simplify anything, just write as it is. This is log 3 cube to the base 25. So apply power rule. So you can write as log 5 to the base 3 into 3 log 3 to the base 25, right? So this 3 you can take it front, so you can write it as 3 into log 5 to the base 3. Now this part I can further simplify, so I am writing 1 by log 25 to the base 3, right? You can interchange that too. So that is 3 log 5 to the base 3 into 1 by log 25 is 5 square to the base 3. So that is 3 log 5 to the base 3 into 1 by, apply power rule again, the 2 come front, 2 log 5 to the base 3. Now listen, you got the answer. This log 5 to the base 3, log 5 to the base 3 cancel. Here we have a 3, in the denominator we have a 2. So the answer is what? 3 by 2. Only the second term we are simplifying, but we simplified 2 times, right? Okay, almost every sum we finished. Look at the last question. Given log 2, log 3 values given, find the number of digits in this expression. Okay, one term given, 2 raised to 8 into 3 raised to 12. 2 raised to 8, okay, you can find. Then 3 raised to 12, that too you have to multiply. The final answer, how many digits are there? Only they asked. So how do we take logarithm? That method we use. Then you find the characteristic. Suppose the characteristic is 3 point something. Characteristic is 3, you say there are 4 digits. Suppose it is 7 point something, then you say there are 8 digits. So characteristic plus 1 you have to do. Okay. So I am taking the number as n, taking log on both sides. So log n equal to log 2 raised to 8 into 3 raised to 12. So apply now the law, first product rule, log 2 raised to 8 plus log 3 raised to 12. Apply power rule, 8 log 2 plus 12 log 3. That log 2, log 3 values given in the question, right? So you can write it as 8 into log 2 value 0.30103 plus 12 into log 3 value given, right? 0.47712. So simplification part you do, you try later. So just I'm giving, this is the value of what? Log n. But here the characteristic is 8. So since the characteristic is 8, so you know the number of digits will be 9. Okay, so there finally you can say therefore number of digits. Therefore the number of digits in, what's that question, 2 raised to 8 into 3 raised to 12 is equal to that 8 plus 1. Your answer is what? 9. Okay. So much all the type questions we finished. 1 or 2 questions I left out, that very simple questions. I think with this idea you can answer any question in logarithm. We'll continue in the next class.